Hello, AP Calculus. All right, here we go. We are going to do Chapter 2.2, number 15, 41, and 55. We're starting off with these. Chapter 2.2 is all involving limits going to infinity or negative infinity. So we start with this one. This one's right here is limit as x approaches negative 3 from the left-hand side of 1 over x plus 3. Remember, the first thing we always do is we do substitution. If I substitute negative 3 into this one, I get 1 over negative 3 plus 3, which is 1 over 0. Anytime we have 1 over 0, that should tell us, hey, we got a vertical asymptote. Anytime you have a number over 0, I can't say that enough. So you have a number over 0, that gives you a vertical asymptote. So we need to test to see if this thing is going to go to positive infinity or negative infinity. So the way that we do that is we put in numbers really close to negative 3, but notice all we're worried about is on the left-hand side. So the left-hand side at negative 3 is negative 3.1, negative 3.01, negative 3.001. If you looked at a number line, you got 0 right here, negative 3. Numbers on the left are over here. So we want to make sure we pick numbers that are on the left. So that's why we go with negative 3.1, 3.01, 3.001. So without even using our calculator, we can look at this, and if we plug in negative 3.1, this is going to be 1 over negative 3.1 plus 3, which gives us 1 over negative 0.1. So 1 divided by 0.1 is 10, but it's going to give us this negative number right there. So that tells me that we are going to negative infinity. Meanwhile, on the other side, negative 3 from the right-hand side, plugging in, if we were to go from the right-hand side, this question doesn't ask that, but this is just me thinking about it some more. If I plugged in numbers negative 2.9, negative 2.99, notice no matter what number I plug in there, that's always going to be positive. So the right-hand side, if we just write this out, the limit as x approaches negative 3 from the right-hand side of 1 over x plus 3, that's going to go to positive infinity. Not what the question was asking, but it is good to look at that and keep on going. All right. Number 41 says to use the end behavior model and figure out what our horizontal asymptote is. Remember, end behavior is baggage. Anything after that highest exponent right there is baggage, so we don't even have to worry about these numbers right here. So we're left with the equation x over 2x squared. The limit as x approaches positive or negative infinity of x over 2x squared. That simplifies to 1 over 2x. Still the limit as x approaches plus or minus infinity. Notice how I keep writing that out. On the AP test, if you haven't done the limit yet, you have to keep writing it out. We plug in negative infinity. 1 divided by a negative big number is going to be approximately 0. 1 divided by a really big number, is also going to be approximately 0. So the limit as x approaches positive or negative infinity, our end behavior goes to 0. Remember, anytime we do the limit as x approaches positive or negative infinity and it goes to a number, that gives us a horizontal asymptote. So this tells us that our horizontal asymptote is at the line y equals 0. Easy. If you guys just take it step by step, then you'll be okay on this one. And that's really, really important when we get to this sketching a graph. So what we want to do is we want to draw a graph that's going to have every one of these things in there. So I look at here, I got the limit as x approaches 1 is 2. So I know right away, if the limit as x approaches 1, that means from the left and the right, it's getting closer and closer to 2. So I know the graph is going to come somewhere right there. It's not necessarily defined there, but it's going to go through that. There at least will be a hole there. Now, the limit as x approaches 5 from the left is infinity. The limit as x approaches 5 from the right goes also to infinity. This tells me a vertical asymptote at x equals 5. So I come over here, I got 1, 2, 3, 4, 5, and I put a vertical asymptote. Okay. Now I know they both the left and the right side go to infinity, so I'm just going to draw that in right now until I see what else is going on right here. Then the limit as x approaches infinity goes to negative 1. The limit as x approaches goes to negative infinity goes to 0. This tells me two different things, but both are the same thing, just in two different places. Horizontal asymptotes at y equals negative 1 and a horizontal asymptote at y equals 0. So I'm going to take this and I'm going to do a horizontal asymptote at y equals 0 and a horizontal asymptote at y equals negative 1. Okay? So that means I know the right side is going to be somewhere close to negative 1. The left side, right here, is going to be close to 0. Now the limit as x approaches negative 2 from the right is negative infinity. And the limit as x approaches negative 2 from the left is also, oh no, that's positive infinity. This gives us vertical asymptotes. So I know at x equals negative 2, negative 1, negative 2, I got a vertical asymptote. Okay, on the right-hand side, it goes to negative infinity. That means this graph goes down like that somehow. This side, we know, goes up like that. Now, when they go to grade on the AP test, they're looking to make sure you have this, and that point in there. Whatever happens here, they're not really concerned at, as long as your graph is going to infinity here, negative infinity there. This side is infinity, so it's going to come down, and it's going to get closer and closer to negative 1 because of this horizontal asymptote. And then this side, the right side, or the left side of negative 2, goes to infinity, so that means it's up here like this. This is going to give us at 0, so it's going to do something like that. So as long as you have this arrow getting closer to 0, this arrow going to infinity, this arrow going to negative infinity, a dot or an open dot or a closed dot there, it can be either or. This arrow is going to infinity, this arrow is going to infinity, and this one's going to negative 1. You would get all the points on that one. I have seen an AP test question exactly like this. Awesome. All right, guys, keep up on your homework. Make sure you're doing it. Please feel free to email me with any questions.